Hi, thank you so much for visiting our paper. Here is a brief overview of it. Because of the technological advancement in the virtual reality technology, multiple people can join in a shared virtual environment from any part of the globe. If they perform collaborative navigation in the shared virtual environment, they can choose either symmetric locomotion methods, like all of them can use steering, or they can choose asymmetric locomotion methods, like they can use a combination of steering and teleportation. So, in this study, we have investigated, in the presence of two asymmetric locomotion methods, how well do dyads acquire spatial knowledge in a shared virtual environment compared to symmetric locomotion methods. To answer this question, we chose two very popular virtual locomotion methods, that is steering and teleportation, and we asked several groups of two people or dyads to experience the asymmetric locomotion methods while performing collaborative navigation. We call this group as asymmetric navigation group. To compare their performance, we also recruited two separate groups of dyads. In one group, both the participants experienced steering. We call this group as symmetric steering group. In the other group, both the participants experienced teleportation. We call this group as symmetric teleportation group. Within each group, the participants had to perform individual navigation, where each individual of a dyad navigated through the virtual environment alone with the assigned locomotion method. Also, they performed collaborative navigation, where a dyad navigated collaboratively through the virtual environment with their assigned locomotion methods. In each navigation phase for every group, there are two phases in the experiment. The first one is the learning phase, and the second one is the testing phase. The learning phase consisted of a virtual maze of 10 meters of side length on each side, where the participant explored for 10 minutes to acquire a cognitive map of it. The testing phase, on the other hand, consisted of the ground and the skybox from the maze environment only. Participant spatial knowledge was tested in this environment. To measure acquired spatial knowledge of the participants, we measure their survey knowledge, which is the straight line distance and direction between two objects in an environment. Here is an example of a participant exploring the maze environment during the learning phase using the teleportation technique. Her position is represented in the maze environment from a bird's eye view for understanding the locomotion method better. During the trials, the participants were placed in front of an object in the maze. By pressing a button on the dominant hand controller, everything was vanished and they were asked to find and navigate to the location of another object from the previously shown object using their locomotion method in a straight line in the test environment. Similarly, during collaborative navigation, dyads learned the environment collaboratively using their locomotion methods. Even though they were physically distributed, they could see and hear each other virtually. Finally, the same way mentioned before, they were asked to test their overall spatial knowledge during the testing phase using their locomotion methods. So, we found that collaborative navigators acquired better survey knowledge than individual navigators, irrespective of locomotion methods. Second, dyads acquired comparable survey knowledge using symmetric steering, symmetric teleportation, and asymmetric navigation. Third, contrary to several prior findings, teleportation enabled individuals to acquire survey knowledge as effectively as steering. Fourth, asymmetric locomotion methods impose similar or less cybersickness than symmetric locomotion methods among dyads. And finally, based on our results, we can suggest developers to support asymmetric locomotion methods in their applications, which might be helpful for the users. Please see our paper for more details. Thank you for watching this video.